Thanks for joining us for this session. Our next presenter is Oliver Morse, and he will talk about the growing value of AI and FME.
I was fortunate enough to go to Bonn just over 18 months ago for the FME UC. An awful lot has changed since then in this space, and I'm really very excited to share lots with you. I really do get a buzz from seeing people kind of getting ideas from what we're sharing. The real key changes over the last 18 months, the advent of not only multimodal models, but cheap and fast multimodal models. Structured outputs, I think I've maybe labored this point too much already, but it's incredibly valuable for us and the way that FME can interact with generative AI. The models are getting smaller, they're getting faster, and in many cases, they're getting much cheaper. And they're good enough for the types of tasks that we want to use them for within any type of data extraction, augmentation, and cleanup processes. There's been a huge drop in price, and that continues apace. And also another one, the advent of no-code computer vision techniques. So this isn't just generative AI, this is a kind of your more well-established computer vision techniques are starting to become more accessible to a wider audience as well. Let's just jump straight into a use case that nobody's seen before. UKPN, we're doing a big project. We've got the service cards. It started off with being a 1 million record task. And I think that's one thing that's quite interesting. It started off with 1 million, then became 2.6 million. Nothing in that whole workflow that we put together changed because FME was capable of scaling up to the challenge, which, yeah, you can't say that about other solutions. Workflow, I can detail that a little bit more. Well, we took these millions of service record cards, we used FME to extract them locally, and then we basically loaded them up into an Azure queue, and then also kept a record of them in Azure SQL database, and we copied them to an Azure storage container. Why do we do this? Well, we did this because we wanted to parallelize the task. We wanted to make sure that we could run FME, utilize multiple engines so that you've got a whole process that can basically pick the next record or next set of records. They're not going to kind of duplicate any type of role or process. And we have a very fast process. There's not going to be any kind of latency issues or over demands on accessing any records from a storage container, as opposed to the constraints of potentially running this type of operation locally. And yeah, saw that I shared the workflow yesterday, but in simple terms, this is what's going on. It's picking up an engine, or the job is picking up messages from a queue. Those messages contain effectively the path in the Azure blob storage to the service card record. FME does that kind of base64 encoding, builds up the prompt to send to Gemini. Out from Gemini, we get nicely extracted JSON, and then we can obviously put that into a SQL database, and we run that really fast, and we run it in bulk. There's always going to be some stragglers left behind whenever there's kind of failures. So using a database and keeping track of anything that's missing, then feature joiner, and then just building up a queue of any remnants means that you can kind of finish off the process and make sure that everything gets captured along the way. I shared this before. The only things I really wanted to highlight is just use this as a kind of judgment call as to the quality of the different models. For the purposes of what we're trying to do, it's not supposed to be the most comprehensive. It's just supposed to be, we want to run all of this and see what we can get out of it, and the value of it is already good enough for us. It may well be that utilizing a Gemini 1.5 or a weaker model is not appropriate for your needs, in which case you'd need to look at Flash 2.0 or Flash 2.5 or another provider entirely. The whole story behind this is it doesn't matter. You can use any one of these tools with FME without any problem, and then have the added kind of reassurance that you can put some rule-based validation in at the end very easy within that FME workflow. It was quite a nice graph I wanted to kind of share, because you have effectively, this is installations that are going on in the east of England dating back from the start of the 20th century. So you basically got that, well, you've got a dip during World War I that you can appreciably see, and then it gets even more weird when you kind of look on a yearly basis, because you can start to see the installations and fluctuations by month. So yeah, we knew that we were kind of getting very good results out of this from an early stage, which kind of gave us good confidence. Probably at this time you're having a few questions or thoughts. How accurate is it? Security, You keep blabbering on about Gemini. We don't have Gemini. And well, okay, we've seen this case study a few times. What else? What else have you got? I mentioned this yesterday. It's really difficult. I mean, there are so many different benchmarks for how good generative AI is at writing code. There's fewer for this kind of extraction of document processes. It's very nice that Omni AI kind of share their findings. This whole methodology that they have is actually completely open and available to test. But the one point about that is, okay, if something else comes along that's better and is at an appropriate price point, we can very easily switch to that. What I find fascinating on this is that you have Gemini 2.0 Flash, which is super cheap, competing against a specific Google document AI. I mean, they're basically taking their own or stealing each other's breakfast in the same company, which is kind of crazy. Yeah. Is it secure? Well, this is the one slide that hasn't changed since Bonn. Basically, in summary, if you're paying, yeah, you should be on fairly solid footing. But the saying goes is, yeah, if you're not paying, you are the product. But in many cases, if your data's open access anyway, why do you care? You're getting free processing from one of these companies and you're getting extracting value. I think it's a kind of a win-win, to be honest. Don't want to use Gemini? Well, HTTP caller, I think, is increasingly becoming like the most popular transformer. It's definitely mine. But if you're not familiar or you're not comfortable building that, there's a whole range of connectors out there. Safe has kind of done a mammoth job of updating many of these recently. I mean, the Bedrock connector is an absolute beast, and a really good piece of work has gone into building that out. Equally, Vinian Tensing, we're proud to be a verified publisher. We've created a range of transformers, mainly because it's just easier for us to manage. If we make sure that we're using our own transformers, we can ensure things are consistent. And as and when any of these kind of services change, we can keep on top of changes just by updating these transformers ourselves. The one to point out there as well is like the local generative AI caller and the Llama connector. If you don't want to use these services, you can run these types of models locally using Llama, and it's an incredibly powerful use case as well. I think in Bonn as well, I was like, it's impossible to keep up with the rate of change. I'm looking on Twitter all the time at what's being released, and it's completely overwhelming. It's got even worse. I mean, the last 4 months, this is what's been released. The thing that's even more crazy, I was kind of checking last night in a bit of a daze, but Gemini 2.5 Pro that came out in April, 3 weeks later, they've now come out with another version of Gemini 2.5 Pro, which is considerably better. So it's really quite challenging to keep on top. However, the most interesting ones for me are the smaller, cheaper models, because they are really fantastic and incredibly powerful at some tasks that we can throw at them. So most recently, outside of the Gemini models, there's the GPT 4.1 Mini and Nano, which are kind of at the same price point as Gemini, who've kind of, along with the DeepSeek effect, has helped to kind of pull down the price of these models. We've talked about in the past, or I think in my presentation, and also Christian, about tokens and context windows. Just to bring everybody onto the same page, a token is like 4 characters long. 1 million tokens, you're talking about 6 books or something like that. Increasingly, models have got larger token context windows. So OpenAI 4.1 that came out a couple of months ago has now got that facility. Images, this absolutely blows my mind. So an image, if you put into one of these models, when it turns into tokens or embeddings, one image is 256 tokens. So it's not quite as poetic as the image tells 1,000 words. Now it's an image is 256 tokens. Hasn't quite got the same ringtone to it. But in terms of cost, it's madness. I have to keep checking this all the time to actually prove out that these numbers are correct. But using the cheapest, most modern Gemini 2.0 flashlight at the moment, you can categorize or do something with 1,000 images for like 2 cents. Like, that's just madnessly cheap. Yeah, we all saw this, but the addition I just mentioned, like OpenAI's got in on the game on the cheap tokens, and I think that's probably to the credit of DeepSeek, which is a stronger model, but has helped to pull down the market as the competition continues to hotten up, basically. Some more challenging tasks. Well, cheat sheet, if you do want to kind of keep on top of this and you don't want to be overwhelmed by Twitter and other news, there's a chap called Simon Willison. He writes like a weekly newsletter, a blog, and he also does really nice evaluations of models. He basically has said that structured data extraction is really the killer app for large language models, and I absolutely agree. We've seen the example of Qualicum Beach yesterday. The thing that kind of blows my mind with this is that you could be saying, well, in the prompt, you're basically trying to extract out this value. And with a large language model, it's somehow saying, okay, I want to get the sanitary sewer information, I don't know, length of connection. And just by a prompt, it's able to know that you're talking about that cell. Is, to me, it's something that every now and then you have to kind of take a step back and appreciate how far we've come in such a short period of time. The prompt here, as I mentioned, we basically wanted to do something a little bit different, convert imperial to metric. The first step in this process was to very quickly do a first pass to extract all the information that we wanted. And then we passed all of the measurements back into a new prompt and said, based on all of this information, if you think it's imperial, convert it to metric. I didn't really have any kind of big expectations. The structured output obviously helps because that effectively confines it to the fields that you want to get back, and enables FME to connect and use the JSON extractor and fragmenter to pull that data out. Just quickly, that's how it looks inside the body of a standard prompt to Gemini, but equally it's very similar with OpenAI Anthropic. And the results back are kind of crazy. Yeah, it absolutely nailed it, including like picking up the character for the diameter sign. It's really quite powerful in the way that it's able to do that kind of further processing, not just extraction, but that cleanup. And then of course you can use rule-based validation afterwards just to double check those numbers. The whole idea of breaking up a challenge with the service card records in UKPN is a big deal. Before you get to this point, there is this whole step of, okay, well, we've got a whole range of different service card styles, so we need to go through a process of classifying these. There's a whole range of different solutions that we could use to this, but let's just try it. Let's just try it with generative AI and see how we get on. So we write a prompt where effectively we've used FME just to crop the top of each of those service cards. We've described what those service cards look like. And we said, okay, well, if it's got these things in it, then give it the ID of 1 and so forth. If you can't find any of these, ID 0. We just ran a process and validated this for like almost 700 records. And it got, out of those, it got 6 or 7 wrong. I was just like, it kind of incredible results just from this type of easy prompting. It just makes it accessible to such a more broader audience. So once we've kind of broken up and classified each of those different kind of templates of record card, then we can really start to go to town with much more specific extraction. So if we just want to get some component, well, we'll basically clip that out in FME, we'll write a specific prompt, and we're going to get some really accurate results back. And yeah, this is the process. No, not too different from what I showed before. You basically are taking in the record cards as before. The only thing is, not only is FME being that orchestration piece, it's also doing a little bit of data prep at the same time, clipping up the record card and putting those prompts. And you end up with quite nice ornate FME workspaces, but ultimately all they're doing is just piecemealing up the challenge that you're presenting, and of course giving that model a lot more chance of success. We've got a really nice one with Beside Energy. They have a task where somebody goes out to the field a couple of times a year, does a bit of a site survey of their solar farms, and then what do? Well, they just dump all the photos in Dropbox and nobody ever looks at them again. Or there's a poor person that then has to kind of file them into different folders. Well, again, this is a very easy task. Once you kind of describe what to expect in those images, using AWS Bedrock and Anthropic Claude, you can build a nice orchestration pipeline in FME to organize those into Dropbox, write a nice summary report, and then flag any issues into a Teams chat. If you want to know a little bit more about that, Simon, a colleague, was part of a fantastic webinar on that in April. So definitely check that one out on the safe side. I said about computer vision for me. Please work. There we go. So we've used a tool called RoboFlow. This has enabled us to do something for UKPN, which was we needed as part of our digitization process to find specific components of these rasters. In this case, we're looking for cross sections. Those types of cross sections are very specific kind of curved arrows. We didn't have any success doing this with generative AI. So we were like, okay, well, are there tools out there that helps us to train a model? This is completely no code. It's absolutely awesome. We gave it a training data set of, a few hundred records. We started to annotate. As we annotate, it learns and then basically starts to make suggestions and makes that whole process of training a model quicker. And then this was a YOLO model that gets created, is hosted by RoboFlow. And then the best bit is that we can interact with it through the HTTP caller and bring it into FME and make it part of a chain process. So we've gone from taking this kind of arrow information that gets identified by RoboFlow. The next step is there's a number next to the arrow. We didn't have much success training a model to find the number as well as the arrow. So next best thing, okay, well, we use RoboFlow to find the arrow. We then use Gemini to extract the number. Well, to do that, first we need to do a bit of a buffer with FME to broaden out the range. And then utilizing the best tools for the best job, we can basically do those types of extractions. No code, and really quite rewarding because it took 3 days to set up. One of my team is completely obsessed by this, by the way. He now tries to do everything with these types of techniques, which is great. But he set it up in 3 days. We typically save 3 to 4 hours per batch. So at the moment, we're 130 odd batches in. We've saved already 59 days of work. There's 380 batches remaining, so that's another 160 days that we're going to be saving at a cost of £250 for a subscription to RoboFlow and about $4 of Gemini costs. I'm really excited by just incorporating. It's not just unstructured to structured, it's structured to structured. And Christian's done some fantastic demonstrations of how you can kind of restructure structured data and standardize it. Combining that with just the fantastic capabilities of FME and dynamic workspaces, schema mapper, schema scanner, feature readers, feature writers, and the advent of DuckDB, there's an awful lot you can do here. Incorporating DuckDB for doing your kind of quick analysis of data sets alongside, and then using FME to kind of feed that information to a Gemini model and then produce some more standardized outputs. Tried to explain this a little bit through the power of shape files. Let's see how we get on. So everyone loves a shapefile. You've got a 10-character limit. Maybe you come across an ancient shapefile and it's got improvement and improvement _1. That's fantastic. I've got no idea what these fields are about. That's really super helpful. What if we could magically go back in time and guess or come up with a proper name as to what they were? Well, we built this little app called the Shapefile Fixer, which you upload a shapefile. And what's going on behind the scenes is FME is reading that dynamically, is converting it into a GeoParquet and passing it to DuckDB to do a nice summarize. So it's creating a summary of that. And then that information, along with a subset of data, is being passed to Gemini to get it to guess a better result. And here it then writes out with FME to a GeoPackage. So now we've gone from improvement to project improvements, and the calmness and issues relating to shapefiles are gone. Maybe not quite, but hopefully you get the idea as to kind of where we're going with that. And then this is just a kind of broad breakdown of the process involved to do this. So it's not just AI, it's cool stuff in DuckDB, and everything, the glue that pulls it all together is those dynamic capabilities of FME. So the schema mapper, schema scanner, feature readers and writers. And this is really where there's kind of culmination of some really exciting things happening at the moment in this space. And alongside FME makes an awful lot of things possible. You can kind of think about this in the way that you want to kind of, there's so many kind of avenues for the ways in which you can apply this to different data sets within your industry and domain. So this was something that my maths teacher used to tell me at GCSE level. He was a Welsh guy. I'm not going to do a Welsh accent, but it was like, break down the problem, make each task because it's so simple, you can't get it wrong. So quick, it takes no time at all, and the difficulty evaporates. And it still stuck with me. But then I was like, oh, well, how does this apply for kind of the AI world? Well, you make each task so simple that the AI can't get wrong. We already know that it takes no time at all for the AI to process. It's now so cheap to run that when you run it at scale, it doesn't really matter. And so that's the kind of position we want to approach things. So just to recap, unstructured data to structured data accurately and at scale is possible now, but equally structured data to structured data is also possible. Techniques to do this are cheap, and most importantly, they're really accessible. We run a couple of training courses now, and people get it I think, I can't remember, what one of the candidates basically said. She said, as soon as you see the workspace, then you kind of, it's like a comfort blanket. You know what's happening here. There's no black box about what's going on, and they can see how they can basically take it forward and apply it. And that's what's so important. We no longer need to wait for better models. The models that we've got at the moment are great for the types of applications that we are very familiar with doing. It's really much more about orchestrating that data pipeline, preparing it. So yeah, thank you very much.
Welcome everyone to our second talk, and today we have my colleague Dimitri taking us beyond data integration. I'll let you take it away.
Okay, so you see this title. I didn't write it, so neither the abstract. Don did it for me in November. Of course, I remember about that 2 weeks ago. But I threw in lots of scenarios I tried in the last 2 years. And my goal is to overwhelm you, not to give you solutions, but give you lots and lots of different ideas how you can use AI within FME workflows, or maybe working with you as an assistant, talking to you and helping you with something what you maybe not very professional at, but with AI you can really be like really good. So you already know me a little bit. So it will be like a rapid firing round. So I will throw the ideas like maybe 30 seconds per idea and move forward. So we will see how many I can do. I have 25. So, well, you will see that a lot of that is about the art of writing prompt. But for our users, we don't want to expose them to these huge, like really long prompts. We would like to make them feel comfortable to expose something very simple, some maybe options or maybe a short phrase, which they can just use somehow and get some results. So let's begin. So the very first one I really wanted to try once I got my AI in my disposal was generating textures for 3D objects. So I would simply ask DALL-E to generate me a texture for a wall, for a roof, and then apply them, and this is it. So you can see the results. They're not perfect, but somehow it works. For walls, it works better than for roofs. We are still probably not there, but we can hope that it will develop more and more. And for many of those things, you will see links if you get the slides, and you can follow and read an article or see an example or download a custom transformer. So another one, setting colors, for example. So if you deal with 3D, you have to set diffuse, ambient, specular color, and that's a lot if you have lots of features. And they just ask ChatGPT, you can ask OpenAI to generate those triplets for you, and you would set them from attributes, and you can specify, use some theme to color, for example, drainage differently than water or sewer or something else. Selecting a projection. So here you can see a user can see only a few options. For example, what they would like to preserve, angles or distances or maybe areas, and for what purpose they would use their map. For general purposes or maybe for navigation. For navigation, you would like to preserve distances. For navigation in the sea, you probably would like to preserve angles. So behind the scenes, you can see a bit longer prompt, right, which I populate with whatever user picks here. And at the end, AI generates a WKT definition of a projection, which we can use in Project Reprojection Transformer and reproject their data according to these settings right away. So another use of DALL-E when I ask to create a wrought iron fence is just a simple black and white image, which I can trace then with portrace color, get vector, extrude, put augmented reality. And here I recreated a city. I was born in St. Petersburg. Very typical scene. This building does not exist again. It's just a DALL-E image and 3D fence right in front of my house, augmented one. This was a pretty good one. So who can write batch files, Windows batch files, or maybe bash scripts? Probably just a few people here. That's dying art, right? So, but it can be quite useful. Again, a user can type something very similar, rename each file, matching this file pattern, and maybe add a date to it. And you can see that phrase goes into my prompt as a very small paragraph. The rest is much longer. So I explain how to write. Well, I don't explain. I ask to create a real batch file, and then I can run it with system caller. And for a user, it's just a magic. Delete me all the files ending with Steve. And that happens right away. But behind the scenes, a lot more is happening. So this one, we can use natural language to create some geography. In boxes for, you can say, for example, a city, use a name, or a description, for example, Benelux, or I don't know, the most western province of Canada. You can use different languages, and you can make typos. Still, AI is smart enough to understand what you're talking about and return you extents, and you can create a geography based on that. And you can ask for more things, for example, pronunciation, local name, administrative unit, and so on. I didn't even know that this language exists. It's a language to talk to OSM maps. And it looks pretty strange. And apparently yesterday I learned that it changed since I created this 2 years ago. One of the hackathon teams used that. So basically just it creates a request for me and we run it, and we can combine the previous and this one and read, for example, bus stops for the downtown Seattle, and it will work. So here we populate some area with painting in with whatever we would ask. For example, who need parks? We just replace them with high rises. We can color use raster algebra to write expressions to color numeric rasters. So good luck finding an error here, but AI would create that for you very easily. I tried also raster algebra with raster convolver. It creates matrices, but not very good. So it can create small ones, but not the big ones. And small ones, usually standard things, work. All the systems have them anyway. I tried Revit. I extracted the rooms, doors, windows, send it to AI, and then I can ask questions. For example, I need a meeting room for 6 people, which meet all the sanitary and fire requirements, and I get the answer what rooms would work for me. You can use, for example, vision models to create libraries for image analysis. Here I threw in 100 images, created descriptions, titles, and tags. And I used ChatGPT to create the database structure and the visualization tools for me. Then you saw those AI agents. I will skip them because I have probably just 4 minutes, or maybe even less than that. You saw that. But if you saw how we can transform voice to text, you can go backwards. You can transform text, for example, an FME error message. You can send yourself, for example, via WhatsApp, or like in this case, I use Slack to send me a message about an error. Here, I tried 2 years ago AI to describe what I have in my workspace, and I'm really happy to see that it's coming right in FME as a standard feature. You saw also this, where I can just draw something on an image and get back vector features back and populate maybe my database with that. I used AI as my assistant to create renderings with FME, and you can create a 8K high quality render from your 3D model with a custom transformer. You don't have to know Blender, you don't have to know Python. Everything is happening behind the scenes. It's just a big script that we wrote together. And the same I did with USDZ and GLTF formats. We can write them, but if we cannot read them, with Blender integration, we were able to do that. So, and that's another project. DALL-E or ChatGPT was really willing to help me to fill those holes in an image, but it didn't work too well. But it suggested me a Python library that can do that, and you can see the results. It also created me this, helped me to create this. You can specify latitude, longitude, and create a shadow. And that what was interesting, I placed this model in Vancouver, but the shadow appeared somewhere in Saskatchewan. And I said, look, it makes no sense. And ChatGPT answered, look, I'm a LLM. I don't have common sense. Seriously, that's what's the answer. So don't try to argue with it, calling for its common sense. It doesn't have it. Of course, I use ChatGPT for my LinkedIn posts. You can see some of the designs, some of them no one saw ever before, some good ideas. And you can see, for example, this one, right? So I'm trying to illustrate my point about creating an AR model with this, and so on. I use it to explain concepts. For example, what is an anchor? What is occlusion, the middle one, or in general, AR. I create icons for our apps. You probably, if you try FME Realize, you will see some of those icons. And this is the most beautiful project I ever created. You would drop a pin somewhere on a map and ask to just set a few parameters, for example, artistic style, realistic, watercolor, or maybe oil painting, and you would specify a season and time, and you would get back some of how AI imagines those locations around the world. So, and if I have 30 more seconds, I found pretty interesting thing there, geospatial bias. I wanted to see where my dad was spending his childhood summers in Lithuania. So, and I would imagine something like you would see in the human's head, but I was getting something like this. Why? Because if you swap the coordinates, latitude and longitude, you would get to Dubai. And Dubai is a lot more a popular location. And AI assumes he cannot want that. Who knows what Lithuania is. Yeah, he really wanted to see something in Dubai. You can read it in here. It's quite interesting. You can see the dialogue. So, and I think, I was able to, Do you feel overwhelmed? No? If yes, then mission accomplished. Thank you.
Hi, everyone. I'll invite Dmitry to join me on stage now, and he will showcase one of the demos from his presentation at the Peak.
So hello, everyone. I skipped a couple of demos because I presented them at our conference during the plenary session. But now, for those who weren't attending that event, I will quickly go over these two examples and we'll show one more. Maybe I should try to keep the same pace. It would be hard, but anyhow. So I hope you can see my screen, and this is a QA AI agent in FME Realize. So where I pick a feature and ask AI to analyze its geometry and its attribute in context of each other. And you see right away that, for example, the AI sees grade is negative, which is not right for the gravity-driven network. Plus, I will run it again. It also shows that if it takes the geometry, I supply the data as GeoJSON. It calculates the length of the geometry, takes the attributes of the upper part of the pipe and the lower part, calculates the grade, and sees that it does not match the attributes, and reports it back. So it's a nice way of checking quality of your data right in the field when you need it. And here is another one where I submit a report. Instead of typing something like, you can see snow, my fingers were freezing. So, and instead of typing a report, I can say something. So I said something in Russian, like, disgusting brown liquid is leaking. We need to fix it ASAP. Yuck. And it was translated into text, and then I submitted it and got back as more professional English. An unpleasant, I will run this again, an unpleasant brown liquid is leaking and urgent repairs are needed. And the rest comes from the attributes. And again, the template was designed by AI for me. So that's all the parts that I skipped during the my presentation, but since we have a couple more minutes, maybe I'll show you what I'm working on right now. So I'm exploring Open3D Python library. I would like to integrate it with FME to add more point cloud processing. And I just can give you a couple of examples, like point cloud surface builder is not very good if points don't have normals, but if you scan something, you don't get normals on that point cloud. So we can estimate them with a simple transformer that I created, but not published yet. And you can see the difference. So you can get something. So you see the point cloud on the left here on the top image. And then if you don't have normals, you get something like a tulip, I don't know. And that's what you get if you estimate the normals with this custom transformer. You still can see some, clouds on top, but they're so dense that it's really hard to get rid of them. And the bar below, you also can see the difference when you don't have normals, and then when you have it. So point cloud surface builder would work a lot better. We also can create clustering, and you can see the results right here, and find outliers, for example, just separate points. I didn't publish those transformers, and let me know if you think FME would benefit. So I didn't publish them because it was pretty hard to install Python libraries. Often, the version compatibility is pretty, hard stuff to deal with. So let me know if that's something you would like to see as a custom transformer in FME. And this is it then. Thank you.
Awesome. Thank you, Dimitri. Yeah, I think we can close out the webinar now. We are at the top of our hour, but I just wanted to thank everyone for attending today. I know we did have a few questions come in, so we will leave the webinar running for another few minutes, so you can save out any links or ask any last questions. If we don't get to your question during the webinar today, we will follow up with you post-webinar. And yeah, lastly, if you have a moment to fill out our webinar survey, we do appreciate any feedback. Thank you, everyone.